Problem is problem 10, practice exam 2. Find dy dx by implicit differentiation. xy equals cotan of xy. All right, so this seems to be a nice problem. So let's try. Okay, so let me write down the equation of the curve. Xy equals cotan of xy. All right. So you're going to take derivative with respect to x of both sides. Fair? So now let's try. On the left, this calls for product rule. Derivative of the first one, second as it is, plus first as it is, derivative of the second dy dx. On the right hand side, derivative of cotan. So cotan of something. So this calls for chain rule. First, derivative of cotan is negative cosecant squared. Okay, don't forget the negative. All the co-functions have derivatives with the negative. All right. So write the object inside as it is. Now chain rule. Derivative of xy. Aha, didn't we just see derivative of xy? So it is 1 times y, that is y, plus x dy dx. So that is your derivative. When you take derivative of both sides. Okay, so now let's continue. I want to solve for dy dx. So I see a dy dx here, a dy dx here. In other words, I need to get them both on one side. So for that, I will need to simplify this a little bit, right? So I leave the left as it is, y plus x dy dx. On the right hand side, negative cosecant squared of xy distributes. So this is negative cosecant squared of xy times y. That's the first product. The second product, negative times a positive is a negative cosecant squared xy multiplies to x dx dy. Okay, now that's looking more promising. So let's try getting the dxy dx dy dx together, right? So why do I have a dx dy? It should be a dy dx. All right, dy dx. Okay, now move this to the other side and get rid of the y. How do I get rid of the y? Y is a plus here, so it goes to the other side, becomes a minus. This guy is a minus here, so it goes to the other side, becomes a plus, and as simple as that. Okay, so because this comes to the left, let me write it here, plus x dy dx equals, okay, this y goes to the other side, negative y and minus. You understand? Y went there, became negative y. This stayed put, so it's stayed put with the positive. On the right hand side, this stayed put, so negative continued to be negative, whereas this guy came to the other side and became a positive. All right, now everything looks more manageable. So you see, dy dx. So I can get dy dx as a factor. So who stays inside? Correct? Who stays inside? First, cosecant squared of xy, and then there is an x, then plus this guy just is an x. Okay, so far so good. Who stays here? That's a, well, all of them stay there, right? So that's okay. Okay, so looks like I can do something, some simplification, all right? Continuing, dy dx equals, I'm going to take this and divide over there. You see, this is a factor on the left, so over there it will go down. In other words, right hand side is now a fraction. The top gets all of this and the bottom gets all of this. Okay, looks like you may leave it like this, guys, but in this case, I think there is a good chance we'll be able to simplify. So notice in the numerator, so again I have a fraction. In the numerator, notice there is a minus y common. Do you see that? Negative is common and a y is common. So negative y. So who is left behind? Here 1 and a plus cosecant squared xy. Okay, check for yourself. Look, negative y times 1 is negative y. Negative y times all of this is a negative all of that y. So that was safe. What happens in the denominator? Look, x is common. So why don't I write the x first? And who remains? Over here, I have cosecant squared xy. And I have a plus 1. Check again. X times cosecant squared xy is all of this. And x times 1 is x. And a plus is maintained by a plus. Aha. Now do you see a hope? Look, 1 plus cosecant squared xy is the same as cosecant squared xy plus 1 because it's addition. A plus b is same as b plus a, is the same thing. So this is reduced by this. All I have now is negative y over x. So negative, I have a fraction, y upstairs and x downstairs. That's my final answer. All right, so dy dx is negative y over x. Let's try. Done. Okay, problem 10. So see you until next.